This week we're going to take a look at some embodied functional anatomy. And we're going to focus on the spine in particular. We'll help to build an embodied, sensing, feeling understanding of this bit of living architecture. And we'll do so by exploring some of the base functions of this anatomical process. So, let's begin with a new model of anatomy, a new understanding of conventional anatomy. It's more to keep in mind that whatever we are, in a physical sense, it's a collection of cells. Now, this stands in contrast to more conventional models of muscle and bone, or even recent fascial models. And yes, we have muscles. Yes, we have bones. Yes, we have fascia. We have tendons. We have ligaments. But beneath all of that, and throughout all of that, are cells. In fact, all of our connective tissues, that is muscles, tendons, ligaments, bones even, into some nervous tissue, they exist within a cellular continuum. And this concept was most clearly explained by Dr. Andreo Spina in his bioflow concept of anatomy. In essence, it's this. Each of these cell types within this connective tissue matrix stems from the same type of mother cell. And then selective pressures or external context cues direct these cells into what type of cell they will eventually become. And so rather than discrete chunks of muscle or discrete chunks of bone, what happens in living tissues, in living bodies, which of course is what we're working with at the end of the day, is that all of these tissues exist within a continuum. And the main differences come down to ratios of cellular components, more so than discrete types of cells. We find that they're made of the same building blocks, and they stem from the same origins. And so rather than think of them as discrete parts, we might think of them as existing within a continuum. And then that leads us to ask, well, how do cells organize? How does a collection of cells somehow keep itself upright in the field of gravity? Why aren't we just cellular puddles on the ground? And the model that best explains this is the tensegrity model. This is a bit of a contraction between tension and integrity, popularized by Buckminster Fuller. And what we see is that this tensegrity model, this balance of tension and compression, manifests itself on the intracellular level within the cells themselves. Intercellular as well, there is a balance of tension and compression between cells, and on up in progressive layers of organization. We see that the bones and muscles act in this way as well. The bones are compressive elements, counterbalanced by tensile elements of the muscles, the ligaments, the tendons, our connective tissues. And so again, we can think of a tensegrity structure, as demonstrated here, a stick and band model, as islands of compression within a sea of tension. And the beautiful thing about tensegrity models is they self-organize. They balance themselves and hold themselves within steady configurations. This structure that you see, much like the body, can keep itself upright in the field of gravity, thanks to a perfectly organized balance of tension and compression. Of course, we can take this a step further and say that we are, in a sense, biotensegrity models. We are living models of tension and compression counterbalanced together. Now, of course, we aren't static, which leads us to interesting parallels between structure and function. Historically, there's been a lot of back and forth as to what comes first. Does structure dictate function? Does function dictate structure? Are they intermeshed? And truthfully, they're both processes, but on different time scales. See, they're constantly in flux, in accordance with the said principle. You know this, of course, that structure can change. We get bigger biceps if we do bicep curls. We gain specific adaptations based on the demands that we impose on the body. So our structures can change. And therefore, we actually tend towards structures because of functions. Now, this is an interesting concept to wrap our heads around, that our structures are in fact dictated by the functions, A, that we do with them, but B, the functions that had selective pressure on them in our evolutionary context. Therefore, we see things like our arms are the structure they are because of the functions of reaching out through space. Our legs have the structures they do because of the function of getting us through space. Our spines have the structure they do because of the function of organizing us within the gravitational field. Now, this is a very different way of understanding anatomy than many of us may have been taught before. But our structures are organized based on both evolutionary context and the functions we perform with them day in and day out. So this happens at all time scales, from the embryologic up to now. It is the function of the organism that dictates the structure as it's developing in the womb. And it's the function that we go through, again, day in and day out, that dictates our structure. And as I mentioned before, these structures are the results of selective pressures on function. We always have to keep in mind the context in which these structures emerged. And they emerged because of certain functions. They emerged as sort of the optimal, the quote, fittest way to solve the puzzle of function within a given context. Of course, if you take gravity out of the equation, we would have a very different structure because the necessary functions would be very different. So, always important to keep in mind what context is at work and how does that influence the functions that are required and therefore the structure. So as with many things in this ecosomatic approach, they are of course interdependent. Just as our function changes our structure, structures in turn can lead to changes in function or performance of function. Think of it this way. As I perform the function of picking something heavy up from the ground, I of course change my structure. I get soft tissue adaptations, neural adaptations. Now, that structural change improves my performance of that function as well. So it's a constant back and forth. It's a continuum. They are, in fact, interdependent. So, let's bring it down and narrow our focus of this week to the functions of the spine. What is a spine for? Both in terms of our ontology and our phylogeny. Our development as individuals and our development as a species. What's a spine for? Well, spine's pretty useful to organize us vertically in the gravitational field. Spine bears the weight of the head and the arms downward through the legs to the ground. Of course, it protects the spinal cord. Huge amounts of our nervous system are protected by the spine itself. It allows orientation of the head within the environment. And this is particularly important for us to keep in mind. Because of course, we're animals that have undergone cephalization. We cluster all of our sensory organs, or the bulk of our sensory organs, at one end. Like most higher order animals, we cluster a lot of our sensory apparatus at one end of our body. And so for us, we have the ears, we have the nose, we have the eyes, we have the mouth. We cluster so much of the way that we learn about the world in one part of the body. And so if that part of the body, the head, is not able to orient and reorganize within an environment, we are at risk. We cannot take in sensory information about our surroundings. And so that puts us, of course, at selective disadvantage if we're looking at it in terms of our evolutionary context. So one of the main functions of the spine is simply to allow easy orientation of the head, the ability to flex, extend, rotate the neck, to scan our surroundings for dangers and opportunities. And the spine organizes most human movement around a central axis. The bulk of what we would consider natural human movements organize around the spine as a central axis. You can think of flexion, extension, side flexion, and rotation as the fundamental building blocks of this spinal movement. And when you look at natural human movements, and human movements in general, you'll see that these spinal movements play a tremendous role in their organization. And so one of the key takeaways is that the spine's function is highly versatile. Depending on the context and the job at hand, it can act as a column, it can act as a whip, it can act as a wave. It has so much versatility built into it, and yet so often we lock it into neutral. As a bit of a protective mechanism, out of fear, out of letting our bodies move outside of neutral. But it's important to regain all of these options of ways of being. And that's what we'll start to dig into a little bit more throughout the rest of this module. But first, let's get clear on the structure itself. In case it's been a while since we've brushed up our copy of Gray's Anatomy, the spine, as you can see here, is composed mainly of three articulating curves. Of course, there's the sacrum as well, but these three curves, the cervical spine, the thoracic spine, and the lumbar spine, are the curves of the spine that are able to articulate. They're able to move. It's made up of 24 vertebrae, with discs in between them that gives them a little bit of cushion, a little bit of spring, and of course the room to move and articulate in a really beautifully large amount of ways. And so of course, if we're breaking it down, our cervical spine has 7 vertebrae. The thoracic spine has 12 vertebrae. The lumbar spine has 5. And you can see that the vertebrae are differently shaped at different sections of the spine. Interesting to think what functions might lead to this structural shape. What are the different functions of the lumbar spine, the thoracic spine, the cervical spine? And how have those functions contributed to the shapes that we see in our vertebrae? We can also see with this many separate joints within the spine, because each of these vertebrae disc articulations is a joint. Spinal mobility is a matter of global organization. We need to make sure that we have proportionate flexibility throughout the spine if we want to have true spinal mobility. We need to make sure that each segment of the spine can move, articulate, and control itself to the utmost. If there is a chink somewhere in the armor, if there is a hinge point that moves too much or too little, then we have a problem, as we'll talk about later. Then we lead to necessary compensations. Now, as for the vertebrae themselves, they're made of a vertebral body, which is the big chunky part. It's what the spinal cord actually passes through. And the spinous process, which is that bony offshoot that you can feel along the back of your body. So go ahead and run a hand along the back of your spine here. Get a sense for what bony landmarks you can feel. And then check in with yourself. Does this knowledge of vertebral anatomy change your conception of where your spine is? So many of us think that our spine and our back are synonymous. But in fact, the vertebral bodies, the spine itself, is a few inches deeper within the body than so many of us think. And if we start to organize our movement and our alignment with this anatomical awareness in mind, we lead to very different ways of organizing ourselves. Rather than the spine being on the back body, the spine is actually closer toward the center of the body than we may realize when we first think about it. So what are some of the typical problems that arise in terms of spinal function? If we're painting with broad strokes here, one of the biggies is movement to the spine, which should be done by more distal joints. Particularly, we see this when the femur is unable to articulate in the acetabulum. When our hips essentially stop working like hips, then we've probably seen this ourselves with many students. The lumbar spine is, of course, forced to pick up the slack. It moves when it doesn't need to move. And when it does so, it loses some of its capacity to organize that movement. It takes on an unfair, undue burden that could very easily be prevented. So that's one of the big problems we come up against. Another is excessive rigidity in the rib basket due to prolonged contraction. And I say rib basket very intentionally because the phrase rib cage seems to contribute to some of this rigidity when we think about it. If I had a choice, if I had a say in the matter, I wouldn't want any part of my body to be a cage. Calling it a rib basket simply gives me the idea that there's a bit of wiggle room within the ribs. And in fact, there is a huge amount of possible wiggle room within the ribs. They're very flexible structures. There's a lot of give and take, expansion, condensation. They're able to move in a wide variety of directions. But with prolonged contraction, we build up rigidity, which of course influences our ability to breathe, our ability to move. It affects our posture. And the funny thing is, so much of this rigidity is brought about by conceptions of, quote, good posture, or what we would think of as correct posture, that forces us into artificial, unnecessary rigidity, which then takes a toll on our overall quality of movement. And another is lack of freedom in the shoulder girdle due to tension in the neck. Now again, in the tensegrity model, we know that on a cellular level, everything in the body ties together. And what we often see happen is that excessive tension in the neck contributes to a lack of movement in the shoulder girdle, and also vice versa sometimes. But these seem to be some of the biggest problems that we'll come up against, some of the most common problems we'll see in our practices. And here's the thing. When the spine organizes well, when we have proportionate mobility across the curves of the spine, when we have adequate control over the functions of the spine, many other problems seem to disappear. When we learn to reorganize the central axis, hip mobility starts to improve, shoulder mobility starts to improve, issues of coordination start to improve. because we've begun to reset and reorganize our central axis. Again, the axis around which so much of our movement revolves. And so if we're beginning a process of embodied functional anatomy, if we want to begin a practice of it, of course we want to start with awareness. And I know this is familiar to you at this point, so I want to give you a quick recap of how we might go about this awareness practice. And to start, you could begin in standing or sitting and see if you can sense into, are you able to map your spine in space? If you're just sitting or standing, like many people, you might have a difficult time getting an accurate map, a felt sense of where your spine is in space. It might begin to get clear to you with a bit of focus, but we often find that there are more effective ways to map out the spine. So you might repeat this exercise in constructive resting position. If you make your way down onto your back, and you start to tune into where you feel weight and where you don't feel weight, it is much easier to begin to map out the curves of the spine to get that embodied sense of your central axis. And of course, you might ask yourself, how does that map change as you spend more and more time in either position? How does your map of your spine change the more time you spend in constructive resting position? Does it shift after a couple of minutes here? And same in standing or in sitting. Does your awareness shift? Does that map seem to change the more time you spend here? As always, can't say it enough, I know you've heard it before, but awareness creates space for choice. When we are aware of something, then we have a choice in the matter. We can make a change. But until we bring it to the level of conscious attention, we are powerless to effect a deliberate change. So, how might we go about restoring some of the function of the spine? We'll begin by looking at flexion and extension. And we have a few practices to get through, so I want to give you a condensed version of them today. And I trust that you're able to practice these on your own time as well. You'll be able to fit them in throughout the week. There's no need to get them all in within one day, although they do make a very juicy exploration if you can really dedicate an hour, hour and a half to restoring movement of the spine. It changes you as a person. So, let's begin with flexion and extension. And we'll begin in constructive resting position. Of course, it's always important to tune in and get a baseline of awareness. What do you notice here within constructive resting position? What can you carry with you from that embodied awareness practice before? To begin this practice, you'll simply press your low back into the ground. That space, that curve that you probably have beneath your low back, you'll see if you can press that into the ground. And then release. And all we're doing at the start is pressing the low back down and releasing that muscular contraction. So you'll find there's some contraction that happens probably in the front of the body that allows you to press your low back down into the ground. And then we just want to release that contraction. And we'll repeat that anywhere from 12 to 15 to 20 times. Moving slowly, moving with control, moving with awareness. You can start to find a comfortable rhythm for yourself as you go through this practice, and as you guide people through this practice as well. Always keeping in mind that you're allowed to tune in. There's no end goal here necessarily. You might just be curious about what you sense within your own structure. Now, after you've gone through this, again, 12, 15, 25 times, iteration is key here. Then we're going to take a look at the opposite pattern, in which you will exaggerate that curve of the low back. You'll begin to arch your low back up and away from the ground, and then release that contraction as well. And again, we will repeat here, taking the low back up and away from the ground, and then release. And as you did before, you can go through a number of iterations here, a number of repetitions, 12, 20, or more. Stick within a range of motion that feels easy here. We're looking for a lack of effort. What's the smoothest you could make this movement? There's no need to reach into your end range of motion here. Now, after you've gone through repetitions there, you can release. And we'll begin to combine those two movements, alternating pressing the low back down, arching up and away from the floor. And you'll repeat, you'll start to oscillate back and forth of that press and that arch, starting to take that lumbar spine through these relative opposites of flexion and extension, bringing gentle articulation to the spine, beginning to flood the nervous system with sensory information about the positions of these joints in space, about the amount of tension held within the muscles. Each repetition we go through here gives our nervous system a little bit more information to put to use. Now again, after you've gone through a number of repetitions, you might pause and check back in with your baseline. If you rest in CRP, ask yourself, what has shifted here? What's different about me than when I began this exercise? Again, the grand changes in the body are built on accumulated subtle shifts. There might not be any massive change at this point, but be mindful of any little changes that you do notice. Now the next process, we'll look at restoring function, focusing on side flexion, the ability to bend left and right. And so once again, we'll begin in constructive resting position. If this is your first time going through this, if you've decided to split it up into a number of sessions, again, I recommend checking in with your baseline awareness here, tuning into what you notice. But of course, you know that by now. So we can proceed right along. And the crux of this process will be sliding your right hand along the floor toward your heel, and then releasing that contraction and repeating, letting the right hand slide along the floor down toward your heel, and then settling back in neutral. And again, you know the routine, although we want to make it as little of a routine as possible. But you know that our goal here is to go through a number of repetitions, moving slowly, moving mindfully, tuning into what we sense within ourselves as we go through this. For anyone who has a knack for numbers, some target they want to aim for, again, 25 repetitions of this. It's probably a good number to aim for. Again, what we're looking for is repetition so that our nervous system gets flooded with information about new ways that it might organize the body. So after you've gone through this process with the right hand, you might pause before moving on and scan through your body to sense any differences between your right side and your left side at this point in time. Then, when you're ready, you could repeat with the left hand. Sliding the left hand toward the heel, releasing that contraction back to neutral, and of course repeat. Going through iterations of this movement, moving at your own pace. Maybe being curious about what feels different in this movement on the left side versus this movement on the right side. Does one side feel easier or smoother? Does it feel like you can reach a little farther with one side or the other? Now, when you're ready, you can begin to alternate, reaching down toward the heel with the right hand, reaching down toward the heels with the left hands, shifting side to side through side flexion. And going through a number of repetitions to give your body a large amount of sensory information. And of course, this is a very gentle movement. It's not a large movement by any means. Thinking back to the Weber-Fechner law, we know that when we reduce the scale of the movement, we improve our nervous system's ability to differentiate and sense subtle changes. Now again, check back in with baseline and ask what has shifted here. Moving onward, we can take a look at restoring the function of rotation within the spine. Now we'll begin in CRP once again, this time with the arms out to the side. And what we're going to do here at the start is let the head roll to the left and let your head roll to the right. Keep it almost a lazy movement here. There's no need to force a rotation. You can almost let your head slosh to one side and the other, as if it were full of water. And in fact, we know that it is. So if we're 70% water, could we move like that here? Could we find an easy rolling of the head to the left and to the right? A gentle bit of rotation, looking out over each shoulder. And once you find a comfortable rhythm, looking right and looking left, you can allow your knees to fall to the opposite side of where you're looking. So if your head has rolled to look toward the right, you could let the knees settle to the left. And then as you switch and look over to the left, you could let the knees fall to the right. So the knees are bent throughout this whole process. And they're moving in the opposite direction of the head, but following the same rhythm. And think here, we're building a spiral from head to tail. Not twisting, but spiraling head to tail. And that intention can totally change how we organize this movement. Now again, after you've gone through this a number of repetitions, you might settle back in constructive resting position once again. And you know by now how to tune in and how to get a sense of what has shifted. Maybe you feel your weight in different places. Maybe you notice new parts of your body in contact with the ground. Maybe you find more ease. You feel like you can spread your weight a bit more, diffuse into the ground. Whatever it is, just take notice of it. And then we can proceed on even further. And what we can look at next is the power of embodied visualization. This comes from a branch of somatic education called ideokinesis, which means thought is a facilitator of movement. The thinking behind it is this. If we are a neuromusculoskeletal event, process, being, and we know that our bones are there to resist the compressive force of gravity, our muscles are there to move the bones, which act as levers and allow us to propel ourselves through space, and all of that is organized by the nervous system, then we know that if we can work at the level of the nervous system, we can affect changes in our musculoskeletal structure. And so what we're doing here is allowing ourselves to get a little creative with our visualization. See, imagined movement engages our musculature as well. And what started as an experiential somatic discipline has, of course, later been confirmed by peer-reviewed studies. We now have empirical evidence showing that, in fact, there is electrochemical activity simply from visualizing a movement. We know that this affects very real physiological changes. Interesting to see when our evidence-based and experiential practices come to the same conclusions. That's when we really know there's something going on here. Now, for a practical example, you might think back to that idea of rising along the front of the body and sinking along the back of the body that we explored in our module discussing gravity. We might think about the top part of the sternum being pulled upwards, gently upwards, by a string. And we might think of dewdrops forming along the sit bones or along the tailbone, gradually increasing in weight, gradually growing heavier and pulling the back body down toward the ground. Again, that's an example of embodied visualization, ideokinesis in action. And I've included a few accompanying audio files that can help you guide this exploration. We'll look at a version in constructive resting position. We'll look at a version in standing, and we'll look at a version in sitting as well. And they might start to get the wheels turning for you in terms of practical applications. What you'll find is that if you want to put this into practice, it helps to get very precise with our anatomical cues. Think top of the sternum, the sit bones or the tailbone, the scapula. Help people bring an embodied sense of these body parts. And then cue for the effects of the movement. Again, when we think about that gravitational exploration, I didn't tell you to get tall. I invited you to think about the sternum rising upward as the tailbone sinks down toward the ground. These are effects within an environment. It's an external focus for us. Of course, we know that our bodies, our systems respond very well to external cues, more so than internal ones. And as a final stop, on this journey of embodied functional anatomy, it's important to clarify one point, that in any joint structure, we are looking for independence of the joint before interdependence. And this idea again comes from the work of Dr. Andrea Spina in functional anatomy seminars, where we look at the ability to move joints independently of each other before we ask them to move together. As mentioned earlier, spinal mobility is a matter of global coordination. We want proportional mobility along each of the vertebral articulations. We know that based on the structure of the vertebrae, they have different capacities to move. You know that the vertebrae of your neck allow you to extend and look overhead more so than the thoracic vertebrae do, for example. That if you were just to move your neck, you could look farther overhead than if you were just to move your T-spine. Based on the structures, they will not have the same amount of mobility, and that's okay. But as long as they contribute equally, they contribute proportionally to global spinal mobility, then we're okay. So of course, if one segment is deficient, there will be necessary compensation. The body is an absolute wizard of compensation. It will do whatever crazy things it takes to get a task accomplished. Because again, it cares about tasks more so than it does form. It does not care how you escape that jungle cat stalking after you. It just wants you to escape it. Good form be damned. It does not care what that looks like. So, it's important to keep in mind that if we do want to maintain good form, if we do want to increase the efficiency and the efficacy of our movements, then we need to ensure that we have proportional mobility, that we have joint independence before interdependence. For example, if there is stiffness in the ribs and the thoracic spine, that could, as you've probably seen with your own clients, force excessive movement of the lumbar spine, in rotation, for example. I see this a lot in clients who golf, for example. Their hips don't move, their lumbar spine doesn't move, their shoulders don't know how to move, and so all of the force of that high-speed rotation comes from the lumbar spine, and it's no wonder they have back pain then. The lumbar spine is being asked to do the work of the hips, of the lumbar spine, of the thoracic spine. All of that burden of mobility is being carried by one segment of the body, by one joint complex. And so the basis of this is that dynamic systems theory shows us that movements will self-organize when the various parts of that movement are in order. That the more mobility, the more independence of the joints we have, the more variability we have in movements. And far from being a bad thing, what that does is equip us to deal with the complexity and the chaos of the natural world. Because we do not always lift things that are barbell-shaped on flat floors in controlled environments. Having mobility, having adequate control, allows us to lift things like couches, like air conditioning units, like heavy chairs, like beds. They allow us to exist outside of anatomical neutral. And so, of course, after awareness comes articulation. And we've gone through a few of those articulation practices in the more somatic sense in the prior exercises. But in the attached video, you'll see a few examples of what we would call our controlled articular rotations that are specifically geared toward helping us increase the independence of the joints. Inside, we'll take a look at rotations of the cervical spine. We'll look at global shoulder rotations. And we'll look at a segmented version of the more familiar cat-cow, which helps us differentiate lumbar movement, from thoracic movement, from movement of the cervical spine. If you couple these practices with the somatic explorations above, you are going to have an entirely new understanding of your spine, entirely new feel and function of your spine as well. And when you implement this with your clients, they will notice a big difference as well. So I encourage you, give these movements a try. You could take a little bit of them and add them to your daily practice. You could make it a standalone exploration. You could break it up however you need. But I recommend you go through each of them at least once to start to get a sense of how that movement affects both your structure and your function.